Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a little mind mapping video on how to really get these identities down and really transfer them from your paper, from your notes to between your ears, because you can't apply what you don't know, right? And one of the best ways you can actually get things in your head is by writing them out and practicing them in multiple ways. And the mind map actually goes through all the identities as you develop them, and then we'll throw in some examples to get to the application of them. Okay, and so the main identity in section 7.5 that we are working with is the Pythagorean identity. All right, so we're going to start off that right in the middle of the screen right here. So get in OneNote here or just a piece of paper. It could be done anywhere. And let's start off with your main Pythagorean theorem. Okay, Pythagorean identity, that is. Okay, and that is cosine squared theta plus sine squared theta is equal to 1. And you'll be surprised what this little identity does for us. It is incredible. All right, and from this, you can develop so many different things. All right, so one of the things that you need to do is understand its variations. Okay, so let's go up here and let's do some variations of the identity. So you want to be able to recognize its variations and you want to be able to see them in your mind. And one of the things you got to do is just kind of play with it. So if you isolate cosine theta, okay, or cosine squared theta is, you get the first variation. So here we go. If you take that identity and just subtract sine squared theta, you get the first variation. All right, so cosine theta equals 1 minus sine squared theta. There's your first variation. Now, these are squares, right? And we know from algebra 1 how to factor things. So this is called the difference of squares, this right here. So we're going to make a little note here. Going back to algebra 1, here we know that a squared minus b squared can be factored as a minus b times a plus b. All right, whenever you subtract two squares, and you might be thinking, Ainsworth, one is not a square. And I say, yo, yes, it is. Okay, it's 1 squared. 1 squared is 1. It's a difference of squares. And so what you want to do is factor this as your variation. So 1 minus sine theta, all right, times 1 plus sine theta. And there you have. That's a variation of your Pythagorean identity. All right, there's another one. So let's go over here. All right. Again, variation number 2 is obviously variation number 1. You could isolate sine squared theta. What the heck, right? Got to get creative. So if you isolate sine squared theta, what do you get? Well, you subtract your cosine squared theta. So this will give you 1 minus cosine squared theta. And guess what? That's a difference of squares too. So this can be factored as 1 plus cosine theta times 1 minus, okay, cosine theta. And again, the order of the binomials doesn't really matter here. I started off with the sum and then the difference. It really doesn't matter. Like the previous one, if you wanted to write it as 1 plus sine theta times 1 minus sine theta, that's fine, okay? The order in multiplication does not matter, okay? So there's variation number 2 right there. Variation number 3. What happens when you divide this identity by, let's say, by cosine squared theta? What do you get? So let's do another one. Okay, variation number 3. Okay, so what do you get? Well, if you divide everything by cosine squared theta, just visualize this in your mind. Okay, I'm talking about the main Pythagorean identity in the middle of the screen right here. If you divide everything by cosine squared theta, things simplify. All right, so cosine squared theta divided by cosine squared theta is 1. And if you take sine squared theta divided by cosine squared theta, you get tangent squared theta. And then on the right-hand side, 1 divided by cosine squared theta, well, guess what? That's secant squared theta. Look at that, okay? Now that's variation number 3, just simply dividing by cosine squared theta. I'm going to write that down, divide by, all right, cosine squared theta. Just do that in your mind, right? And you should be able to generate this. We're in pre-calc here, all right? So let's get a little creative here. What happens if I isolate tan squared theta? Because you might have to do that, right? Well, if you subtract 1, another variation of this one right here would be equal to secant squared theta minus 1. Well, oh my goodness, look at this. This right here is a difference of squares again. And guess what? It could be factored into two binomials. So your factoring skills have to come into play here. We're talking about algebra 1 factoring skills. Okay, so at the very top here I said algebra 1 factoring skills. This is an important one here. The GCF is another factoring skill that we'll talk about, but the difference of squares comes up a lot, my friends. All right, so you got to go back to basics. So let's factor secant squared theta minus 1. Okay, now we know that secant theta times secant theta is secant squared theta, so it's got to be the first terms. And then you got to go plus 1 minus 1, all right, in either order. All right, and there's a couple variations of your main Pythagorean identity. Well, I didn't have to divide by cosine squared theta. I could, divide by sine squared theta. All right, so here's another variation. So let's get some room. All right, variation number 4. And if you divide by the sine squared theta, because we haven't done that yet, you get a new identity, okay? And so visualize this. Divide each of the three terms by sine squared theta and write down what you get. And cosine squared theta divided by sine squared theta is cotangent squared theta. So we have cotangent squared theta. The second term is sine squared theta in the identity. Divided by itself, you obviously get 1. And then 1 divided by sine squared theta is cosecant squared theta. So once again, you have to know your basic identities from prior lessons, right? And then you kick in a little bit of algebra factoring skills or isolation skills, and you're good to go. Now, if I isolate cotangent squared theta, all you do is subtract 1. So here's another variation. You get cotangent squared theta is equal to cosecant squared theta minus 1. But you're looking at that and going, you know what? This is factorable. And so this is, you factor it, right? It's a difference of squares. Is that illustrated multiple times here? So this is cosecant squared theta minus 1 times cosecant, excuse me, I didn't mean to say the square if I did. Just cosecant theta minus 1 times cosecant theta plus 1. So there's another variation of the variation. Man, we're getting crazy here. All right, but this is what you guys got to be able to do is manipulate all these different things and rewrite functions in terms of other functions. All right, and then apply, of course, your basic algebra skills. Okay, so I think we got the variations down here. Let's do some simplifying. Okay, so let's see here. Let's take a look at an expression. Okay, so here we go. Simplifying. So here are some of the examples. So simplify. Okay, so I'm going to make up an expression. All right, when we simplify here, we want to take a complicated expression and write it in simpler terms or as a single term. So in your homework, it said, try to write the expression, okay, write the expression, okay, as a single term, okay, to simplify it, okay, make it from complicated to simplify. So, here's an example. So let me make one up here. So, and this is something I wouldn't expect you guys to do. You just do your homework, okay? But I'm an instructor, so there we go. Okay, so let's suppose I give you this guy right here. 1 minus sine squared x divided by cotangent squared x. And notice that I switched variables from theta to x because you guys got to get used to different variables and it really doesn't matter what the input angle is. You just have to learn to work with it. It could be alpha, beta, any Greek letter of the alphabet. Because in mathematics, man, we use them all, as you know. Okay, so here we go. There's different ways of doing this right here. So we wanna write this, as one expression, as a single term, as I say over here off to the right, as a single term, right? Okay, so what do we do? Well, I recognize 1 minus sine squared theta. That's part of the main Pythagorean identities, and that right there is variation number 1. Look at that. Okay, we know that 1 minus sine squared theta is cosine squared theta. Okay, so this is equal to now, so put an equal sign, right? The numerator is cosine squared x. All right, the numerators, this is your main Pythagorean identity written in a different way. Okay, so what do we have? We have cosine squared x divided by cotangent squared x. Well, what in the world is this? Well, let's see here. I know that cotangent squared x is defined to be cosine squared x divided by sine squared x. So I could write it as cosine squared x divided by this fraction, right? So cotangent squared x is cosine squared x divided by sine squared x. So I have a fraction within a fraction. Okay, so what do you do? Well, you go back to grade school and you go back to fifth grade and you multiply by the reciprocal. Okay, so from here to here, we want to multiply by the reciprocal. That's what you should have been taught back in the day. All right, so I got to reciprocate this fraction down here. So here we go. So my numerator is cosine squared x times the reciprocal of that fraction in the bottom. So you take the reciprocal, and that's sine squared x divided by cosine squared x. And then you simplify, like the directions ask you, right? So anything divided by itself is 1. So simplify the cosine squared x, and you get a very simple expression called sine squared x. There we go. And that is just a very basic example of how to use the identities. And again, it was variation number 1, all right, to simplify an expression. Again, all we did was variation 1. But you wouldn't have known that had I not go and talk about that, right? So you take your main Pythagorean identity in the middle, which is your cosine squared theta plus sine squared theta equals 1, and you practice until you have these variations in your head. And then when you are asked to use them and apply them, well, guess what? You can, all right? So let's do another one. Let me throw in another example here because the whole intent of this video is to teach you how to practice properly and how to apply what you learn, okay? All right, so let me come up with another expression here so we can kind of play with it. Okay, here's another one. So simplify this expression here. We have sine squared x plus cosine squared x divided by tangent x. What is this guy equal to? Okay. Now, what I suggest you guys do is, if you're watching this video, all right, is go ahead and pause the video and give it a shot. All right, pause it. And I'm assuming you gave it a shot, okay, because you're honorable and you have integrity. You're here at Great Oak, and that's what we do in the schools. We have integrity. That's part of our school acronym, okay, SPIRIT acronym. So here we go. So the numerator, guess what? That's your main identity. All right, so the numerator is just 1, my friends. Okay, so 1 divided by tangent x. And then in my first video lesson here, or in previous lessons here, I say always be right in terms of sine and cosine. Okay, so this is actually 1 divided by sine x divided by cosine x. And then here we go again, we multiply it by the reciprocal again. So 1 times the reciprocal, which is cosine x divided by sine x, which is the definition of cotangent x. Okay, so there you go. There's one little example, a very simple one. All right, so that's example 2. So far I've gone over the identities first. They're on the OneNote here. They're on your paper, right? They're right in front of you. You generated them, and now you get to use them and apply them. All right. So let's try another one. Let's go down here and work on just one more here, just to get some more experience. Okay. So this one is going to be a little bit more complicated. So how about? Well, no, I don't want to. Oh, we'll build up. Okay, not too complicated. So let's try 1 minus sine squared x times 1 plus tangent squared x, and let's see what we get. Okay, now again, once again, you have all your identities here, right? So you can obviously look at them, right? So 1 minus sine squared x, guess what? That's equal to cosine squared x. So this first one here is just cosine squared x in disguise times something. What's 1 plus tangent squared x? Well, it's up there, okay? It's variation number 3. That's secant squared x. So again, so that's variation one, or yeah, variation one, and then variation three. Look at that. Variation number one here, variation number three here. So like I said, you wouldn't be able to do something so simple, even though it's simple, unless you know all the different variations and you have them either in your mind or like this right here, right in front of you on one single page. All right. And so that's why we did the mind map first. All right, because you wouldn't be able to do any of these little simple problems unless you have this in front of you. Okay, and then of course you got to continue here because you have to simplify because that's what it says, right? So I know secant squared x is the reciprocal of cosine. So again, I've taught you in many videos that you rewrite in terms of sine and cosine as your first basic skill. So this is 1 divided by cosine squared x. Well, guess what? Right there, guys, when you divide anything by itself, okay, you get 1. So this is equal to 1. All right. And let's do another one here. Let's do one more right here. So example 4. Okay, and let's simplify this one. So example 4 down here. Let's take a little bit something a little bit more complicated. So let's say secant squared x minus 1 divided by secant squared x right here plus, all right, plus 1 plus sine squared x. Oops, oops, oops. Change that. Minus 1 minus. All right. Change that. Okay. So here we go. Example 4. Now, secant squared x minus 1. What is that? Let's go fishing. Okay. Let's go look at all the identities right here. Is this an identity? Is secant squared x minus 1 an identity? And the answer is yes. It's variation number 3. Look at that. If you solve for tangent squared theta, you get secant squared theta minus 1, and that's what we have in the numerator. So this is actually variation number 3. So to go from here to here, we're going to use variation 3, and we know the numerator right there is simply tangent squared x. That's it. So we have tangent squared x divided by secant squared x. All right, and now this portion here, the 1 minus, okay, the 1 minus sine squared x, you know what that is, right? That's variation number 1. Okay, that's actually equal to cosine squared x. So again, it's recognizing what you're dealing with based upon your experience earlier in the initial mind map where we put all the identities out there on paper. Okay, and then so this is actually equal to cosine squared x. All right, now let's zoom in here and let's take a look at what we have. And then this fraction here, it can be simplified. So you always rewrite it in terms of sine and cosine. So tangent squared up top is your sine squared x divided by cosine squared x. Down below, secant squared x is 1 divided by cosine squared x. So you have to know your basic definitions because if not, you can't do anything in mathematics, okay? You're at this level in pre-calc here, you have to know all your basics really well. And if you don't, then you're not studying right. Okay, so go home and study differently, like this right here, like I'm trying to show you guys. Okay, so now we multiply by the reciprocal, or there's a cool slick idea. You could multiply by a form of 1 here. A lot of teachers do that. You could multiply by cosine squared x on numerator and denominator, like so, like this right here. I don't know if you guys were taught this right here, but this is a really slick way to do it. This right here is called a form of 1. Form of 1. Notice that cosine squared x divided by cosine squared x in red right there. Well, that's actually 1. That's why I call it a form of 1. But what's cool about it is that if you use this technique with fractions, like within fractions, fractions within fractions, watch what happens. Okay, so in the numerator, the cosine squared x cancel. In the denominator, they cancel again. And then all you get is sine squared x. And that's why this is a slick technique. So if you haven't seen it, there you go. Or you can multiply by the reciprocal. You could do that too. But you get cosine or sine squared x here on that fraction. The only thing that's remaining is this sine squared x, right? Bring down the cosine squared x. Okay, and guess what? That's just equal to 1 because that's your main Pythagorean identity. Okay, there you go. Look at that. And there's four examples of using your identities. And the only way you get good at this stuff is by doing what I just illustrated right here. Go through the identities, go through a mind map of all the identities and start practicing. And you're not experienced enough to, come up with these examples on your own. So what I was doing, and you didn't know this, is that I just used the examples in your homework. Okay, all four examples are from your 7.5 homework, guys. Okay, that's it. And I was just going through them and practicing with you. But the key, as I'll say this again, the most important thing that you guys need to do is you need to brainstorm and practice the right way. You need to go through the identities because if you can't write them, you don't know them. All right, that's one thing for sure. So do the brainstorm activity first, get all the identities and their variations out there on paper, and then start applying them. And then you'll be surprised on what happens. You'll be surprised how much more confident you're going to be and how much better you're going to be in class. All right. So this is Mr. Ainsworth here. I work at Great Oak High School. Hopefully this helped you out. Take care. Bye bye.